Hi there. Some people had trouble with the quiz for page 7 and 8, so I'm going to work through two of the problems here. Okay. Um, First graph you're going to make, hopefully you won't have trouble with this. F of x equals x squared. If you're bad at putting numbers into x and calculating them out, I would suggest that you memorize 5 or 6 important functions such as log base 10, natural log, x squared, x cubed, e to the x, 1 over x. I think that's pretty much it. If you memorize those, I think you're going to be in good shape. So, actually the values to graph a parabola, the basic parabola, are 0, 0, 1, 1, 2, 4, negative 2, 4, and 3, 9, and negative 3, 9. Hopefully that looks familiar to you. You remember, you can just like plug values into your calculator, or just do arithmetic to find those values. So you don't have to memorize it. But if you have a lot of trouble, graphing that, maybe you should memorize it. Okay. So first transformation we're going to do is a translation. And remember that if you have f of x with something added to it, then this is a translation in the y direction. But if you have something added or subtracted inside the parentheses, that is in the x direction. So, and it's kind of the opposite of what you would think. When it's negative 1 inside the parentheses, it's actually moving to the right instead of to the left, okay? So we are going to take our parabola and we are going to move it to the left. To the right, I'm sorry. Ta-da! Isn't technology wonderful? There we go. So we've moved it perfectly to the left. But of course, if you aren't doing this with a pad like an iPad like I'm doing it, then just remember that you are just shifting everything. On each point, you're shifting 1 unit to the right because it says x minus 1. Okay? And one way you can remember that x minus 1 shifts it to the right is, what you could do is you could say, okay, I am going to see what point is it going to be at x equals 1. So you put x equals 1 in here, and then you end up with f of 0. Okay, so basically when you put x equals 1 in there, you get, oh, what's the y value at f of 0? The y value at f of 0 is 0. Okay, so then you find out that the y value at f of 1 is now 0. Okay, and if that didn't make sense to you, then forget that approach. Okay, just memorize that when you have x minus 1, it's a shift to the right. When you have x plus 1, it's a shift to the left. Okay. Our next transformation has the negative 1, which we already did, and this time we are going to divide the x value by 2, okay? And when you divide the x value by 2 inside the parentheses, then you are doing an expansion by a factor of 2 in this case, okay? You're doing an expansion or a stretch in the horizontal direction. Okay? Remember, if you have a value outside the function, that is stretching in the vertical direction. So if you have a number inside the parentheses, then you're doing a stretch or compression in the horizontal direction. When you have a horizontal inside the parentheses, it's like kind of the opposite of what you think. So if you have it divided by 2, that's actually stretching it by 2. Okay? So now I'm going to take the original 1, and I'm just going to copy it here. Copy this again. I'm going to put it down here, and first I'm going to position it exactly where it was. It was shifted over 1, right? And then I'm going to stretch it. Okay, when I stretch it, I'm going to use a different colored pen. And the way the stretch works is, at least when you have it in this format where there's the x divided by 2 and then subtract 1 afterwards, you are going to take each of the points and move it farther away from the y-axis. So, for example, this point here, it's 4 from the y-axis. We're going to double the distance because we're dividing by 2. We're stretching by a factor of 2, so it's going to go from 4 to 8 over. So now it's going to be here. This one that's 3 is going to be 3 more over. It's going to be here. This one that's 2 over, it's going to be moved 2 over. This is going to be 1. And the funny thing is, the 0, 1 point, it's going to remain exactly where it was, right? Because everything is moving farther away from the y-axis. If you're on the y-axis, you're not moving anywhere. So this is moving 1 more to the right, left, and this is moving 2 to the left because it was 2 away from the y-axis. Now it's moving double the distance away. And now if I connect these dots, you can see that I'm basically making a very wide parabola. So that is the new function, the transformation, which is a horizontal stretch by a factor of 2. Okay, we just did that. Now the new thing is we're going to multiply the function by a factor of 3. And if the 3 is on the outside of the function, that means that we are stretching in the vertical direction. So if we are stretching in the vertical direction, then we are going to take the original function, which is, let's see, it's the blue function here. Okay, so I'm going to try to erase the red function and the other lines. See if I can just leave the blue function. Pretty hard to do. Okay. Now I am going to stretch it in the vertical direction by a factor of 3. So, and that means anything that is not on the x-axis is going to move farther away from the x-axis. Anything that is on the x-axis is going to stay right where it is. So, this point's on the x-axis, it's going to stay where it is. This point here, 4, 1, is going to be stretched from the x-axis by a factor of 3. So instead of 1 high, it's going to be 3 high. And this one too. And then, negative 2, 4, that's going to end up being negative 2, 12, which is like off the screen. And this one is going to be 6, 12, also off the screen. Okay, so now it became kind of a narrower parabola, right? And then finally, in the last frame, it's going to do a vertical translation down by 2. Okay, and so I'm going to put it back where it was. And then I'm going to erase. I'm going to erase everything except for the purple part. Okay, and then I'm going to move it down by 2. I think the easiest way to do that is if I just copy. Okay, so I'm going to move it down by 2. Right there. Okay? I think especially my upper dots don't look that good. But so I've lowered it by 2, because if you have a negative 2 at the end like that, or minus 2 at the end like that, basically you're lowering it by 2 units. And that's it. Now I'm going to go do one of the exponential ones. So let's do this one. So in this case, I'm going to first graph 2 to the x, and this is one of the graphs that you should memorize if you can't just plug in numbers and do it. But basically, remember, whenever you put x equals 0 in there, 2 to the 0 is 1, right? If I put 1 in for x, then 2 to the 1 is 2. If I put 2 in for x, 2 squared is 4, okay? And this should be enough to get you started. I mean, once you graph these 3 points, it's pretty obvious where the function is going, right? Here, it's going to the asymptote. If you want to put 3 in there, it goes 3, 8, all right? So that's pretty much what it looks like right there. Okay, so that's the original function. Now that we have the original function, let's do the first transformation. The first transformation is I'm going to do x plus 2, which when you have x plus 2 inside the parentheses, that means you are translating horizontally to the left, okay? So x plus 2 would be to the left. So I'm going to take this function that I drew, I'm going to copy it, and then I'm going to paste it in, except now I'm going to move it, so like there's the original position, I'm going to move it 2 to the left, so it's going to be 1, 2. Okay, so like all the points have been moved 2 units to the left. Okay, so if I look really closely at each one of these points, I can see that this point, for example, was originally there. I moved it 2 to the left. This point was originally there. I moved it to the left. This point was actually originally 2, 4. I moved it to the left. And this point was 3, 8. I moved it to the left. Okay? So you can see that the whole function moved 2 to the left. All right, the next step is I'm going to do a horizontal stretch by a factor of 3. Okay? So I'm going to take this original, or the second function here. And first I'm just going to copy it here. Okay, it's now there. Okay. And now I'm going to do a horizontal stretch by a factor of 3. So any point that is not on the y-axis line is going to get moved farther away from the y-axis line by a factor of 3. So, for example, this point here, 1, 8, is 1 unit away from the y-axis. It's going to move up 2 more units away because it's now going to be 3 times as far from the y-axis. And this point here is just going to remain on the y-axis because it's on the y-axis already. And then this point, negative 1, 2, it needs to move 3 times farther away from the y-axis. So instead of being negative 1, 2, it's going to be at negative 3, 2. And finally, negative 2, 1. Instead of being at negative 2, 1, it will be at negative 6, 1, because it's going to be 3 times as far also. So that's what we get. We got a exponential function that is much kind of flatter. Okay. Next step. Next step, we are going to multiply the whole function by 2, which means it's going to be a vertical stretch by a factor of 2. And I'm just going to put this here. Okay, and then I'm going to try to erase the red one. Okay, all right, that's pretty good. And now I'm going to try to move this purple function away from the x-axis by a factor of 2. So, for example, this point here, which is at negative 6, 1, it's going to go to negative 6, 2. Negative 3, 2 is going to go to negative 3, 4. 0, 4 is going to go to 0, 8. And after that, it just goes off the screen. So let's try to follow those. Okay, so the orange function is the new function, which has now been moved twice as far from the x-axis. Last of all, we will lower the orange function, or we will raise the orange function by a unit of 1. So we're going to copy this, and we're going to put it down here, except instead of putting it here, I am going to raise it 1 unit. So I just raised it 1 unit there, and I'm going to erase the purple one so you don't get confused. Okay, so I can see that originally my orange function was 0, 4. I went up 1 unit to 0, 5. Originally I was at 3, 8. Now I am at 3, 9. Originally I was at like negative 3, 2, and now I'm at negative 3, 3. Okay? So I have moved the orange function up 1 unit because of that factor there. Okay, so that's just a like a non-algebraic way of working through these transformations. And whenever you have the function and you have the transformation, all you need to do is plug in, the binomial or the linear function into the function, and then you just start plugging in numbers. But I saw that a lot of you have trouble doing that, getting consistently correct numbers out. So if you have trouble doing that, don't do it that way. Okay, just memorize a few different transformations, and then you can go far with those. All right, and sometimes you're going to get problems where they don't give you the function. They're going to give you like a drawing of a function, and the drawing of the function needs to be translated even if you don't know the actual mathematical expression that describes it. Like, for example, I think we had a book problem where we had like a weird looking function like that, and it says, oh, what happens if you do 2f of x? And then you need to do just what I just did. You need to like take each point in here and modify the position using what you know about what this means. It means vertical stretch by a factor of 2. Okay?